Hello YouTube. In this video I'm going to be picking up where I left off and trying to fix this RTX 5090. So if you remember in part 1 we took the core off the cracked PCB, we reballed it, and we've transferred the core onto this sketchy AliExpress PCB. So the card shows up in Windows, which is as good as I can expect at this stage. Obviously it's got no memory, so it won't run properly, but it seems to be showing up as an RTX 5090, which, to be honest, I'm not really sure I expected. I thought we would run into problems at this stage because of the low resistance on all of those rails. So the next thing we've got to do, so we've got 16 chips that are all 2 gig each. We've got to remove the old solder, add some new solder balls, and fit them to the board. Then we can see if our hard work's paid off. So, let's get you under the microscope and start cleaning them up. Okay, all the video memory is cleaned. For anyone that cares, my wick is Edson solder sip. I'm using 2.5mm. The reason it's silver rather than a copper color like most wicks is this is pre-tinned. And I really like this wick. I've used it for a long time and it's by far my favorite. It's quite gentle on boards, doesn't scratch or damage anything too much. It's quite expensive, but it's really good wick. So if you're looking for a good wick, this stuff is good. Okay, so we have our memory and our magnet and a stencil. This is an Amio stencil. It's a different brand to the stencil I use in the core. I don't like this brand quite as much. I think this stencil is going to flex when we apply heat, so we're going to have to be careful to watch that and make sure we don't apply too much heat, causing the stencil to warp and the balls to roll around. Just gonna, oh, I forgot, I need to add my thing. Alright, now we're safe to apply some flux. I'm going with the Solder King halogen free tacky rework flux to reball these, and then I'm going to use the liquid flux after just to do a second pass. I'm going to do these 6, followed by the next 6, followed by the remaining 4. And hopefully the stencil doesn't give me too much grief, but there's only one way to find out. Let's see how we get on. Shiny. Do you want less light? There we go. Is that better? I wonder what size solder balls this uses. On GDDR6, I would usually use 0.45. This is GDDR7, there's more contacts in the same exact area, so I think I'm actually going to use 0.4mm solder balls on this. Probably slightly smaller than the holes, but that's going to make my life a little easier when it comes to applying the balls and removing the excess. It's also going to make it a bit easier to get out the stencil. So let's pour some of these on. stragglers. Right, because I don't know how this is going to behave, I'm going to go a little bit lower on the temperature than I would usually. As I say, I have a feeling this stencil is going to flex, and I'm going to try and keep moving the heat around the stencil to try and keep the heat vaguely even. It might work, it might still flex. Who knows? So I'm going to place my tweezers down. See if that helps. There's not two balls in there. No, that's just the pad. Okay. The reason I think this stencil might flex is because I had the same brand stencil for GDDR6. I had the same brand stencil for GDDR6, and it really was awful. The moment you applied any heat, the stencil would just bubble up, all the balls would run away. It was just a bad experience in general. So I'm really hopeful that this one's a little better. But it seems to be so far. I think I'll get away with upping the heat. So far so good. Just zoom you in a bit and see if there's any that don't look quite right. They look okay. So far so good. I take it back, the stencil's good. That was painless. It's that one in the middle there, that's not quite soldered. Oh, one of my balls fell off. But nothing we can't fix. Oh, there's a spare one there. Perfect. I'm just going to borrow that. Put that over there. Add some of the magic liquid flux. And give it a second pass. I think that ball there looks a little abnormal. It's just a bit pointy on the top. But I think it's okay. Everything else looks okay. So, there's the first 6 done. Oh, I expected them to all fall out of the stencil. Guess I'm going to have to remove them with tweezers. We're all stuck into the template with a bit of flux. Right, that's 10 to go. Try and keep my stencil relatively clean. The more fluxy it gets, the harder it's going to be to apply balls. Normally, I would ultrasonic clean my stencil between sessions, but I don't have time for that today, so I expect with each time I use it, things to get a little bit trickier and a little bit stickier. I just noticed something. So this lid says 0.4. So I thought I was using 0.4 mil balls. But the side of this container is 0.45. The lid's obviously got switched at some point. So earlier in the video when I said I was going to use 0.4 mil, I was wrong. Oh well, seems to work. Okay, we appear to have lost 2 balls this time. That's not so bad. Just put them back on. 12 down, 4 left. If you've got a situation like this, I would recommend you Captain tape the additional chips that aren't populated. However, I can't find my Captain tape, so we're just going to have to accept the fact that we're going to be wasting some balls. At least they're cheap. Oh, come on. Stay in the hole. There we go. Okay, we're looking good. So, as you might have noticed, I've been putting all the VRAMs in this little basket. I'm going to put them through the ultrasonic cleaner to remove some residual flux. I'm also going to chuck all of my templates and dirty stencils through. And whilst that's happening, I'll put the PCB on a heat mat and get it up to temperature ready so we can start removing residual solder from the board and fitting all those memory chips. Should probably also clean the balls off my desk. Okay, that should be hot enough. Now the reballing went way better than I expected. I've been filming about an hour. So just for reballing the VRAM, it's taken me probably just less than an hour, but then a bit of time to clean up and that sort of thing. So now all that's left is to fit the memory, and then we can retest it. I'm going to clean up the pads. I'm going to use the M35 flux again, and I'm probably going to use my heat gun and some wick, small pieces of wick cut up, just to brush across when it's hot enough. But the PCB should be relatively hot now. Should hopefully be easy enough to clean up these 16 VRAM sites, and following that we'll get the memory back on. Good a place as any to start. I might just shield these caps because they've got plastic bases and we don't want to melt them. That would just kind of look ugly. What can I use? Just gonna, will that work? Just pop a razor blade up against it whilst I clean these ones up. The board seems to be cleaning up real nice. Things seem to be going my way today. I don't want to jinx it just in case we run into some problems later, but this is going way smoother than I expected, this entire process. So let's keep going. We've got about halfway there, nearly halfway there with the cleaning. Got a couple missing caps around here. I'm going to see if I can get any high-res photos of this PCB and just replace the missing passives where they're necessary. I won't have a board view or schematic, but you know, we can assume these caps are probably on VRAM. Hopefully the high-res image, if I can find one, will tell me if there's any missing resistors or anything like that. But I mean, this is showing up in Windows, so there can't be too much wrong with it in terms of power rails. So that's good. Anyway, let's clean it up some more. There we go. PCB is prepped. And we have the VRAM ready to go on. So, not much more to say really. I'm just going to add some flux. Going to make sure the orientation of each chip is correct. I'm going to do these two first, and then I'm going to do one side, stop for a second, next side, stop for a second, next side. So I'm going to do each side at a time. I don't know. Just easier to place a couple at a time rather than do all 16 at once. Add some of the good stuff. I might stop every few chips and just don't know if I should check for shorts. I mean, the resistance will be very low because the board's really hot, but as long as it's not zero, we should be good to keep going. So chip number 1 and 2. And the white dot is in the top right corner. And the arrow is in the top right corner as well. Good. Must be a little bit of solder on that corner or something. The cleaner the area is, the better you've wicked it, the more easily these are going to knock into position. But the surface tension when the solder starts to liquefy should bring them in. So let's get this one soldered. And hopefully we'll see it shift a little bit as the solder starts to melt. If not, we can always give it a little tap, but we've got to be careful if we do that. That appears to have soldered. The orientation on this chip's correct. There we go, that's just shifted into spot. Okay, 2 down. There's just a tiny bit of solder that I didn't properly clean on this one. Just on that top right corner. I'm too lazy to go back and clean it off, so I'm going to try and See if I can get it into alignment anyway. No, there's too much there. I'm going to have to quickly correct this. Well, it should work. Okay, chip 3, 4, 5, 6, 7 appear to have all soldered okay. I'm going to quickly check the memory resistance. You're just going to have to take my word for this because I'm far too lazy to turn on OBS and record my multimeter here. So we are getting 1.5 ohms, which given how hot the board is actually a good thing. If it was 0.6 or 0.7, if it was dead short, that would be bad, but 1.5 just suggests that memory is there and very hot. The hotter a board is, the lower the resistance is going to be. So that's normal. 1.5 is normal. When the board cools down, the resistance will climb. Let's go for chips 8, 9, 10 and 11. And down to the final 5. I wonder how long have we been going? About 14 minutes to clean and fit the VRAM so far. Gonna need to finish this pretty quickly now because I'm gonna have to open the shop. I'm using quite a generous amount of flux. I wouldn't usually use this much flux, but the board's hot, so it's spreading really nicely and easily. And I don't want to risk there being any dry joints, so this is okay. I think I said earlier in this video that this flux responds really well to my ultrasonic cleaner, so if I apply a generous amount, it's still going to be relatively easy to remove. There we go. We have all 16 things soldered to the thing. I'll clean up some of the flux. Right, I'm going to let that cool down, and then I can check memory resistance one last time before we decide that it's okay to plug in. Oh, I should check for those missing passives as well, see if anything's important. Okay, we've got the memory on. Let's take a look around the board. Just want to look for any missing components because I think there might be a couple missing components around the memory and around the core. So, let's get on the microscope and get you in focus. I'm going to start around there. You can see a couple that could be missing there. I'm just going to be comparing to the original board, just to see if the original board has the same components missing. The layout's not exactly the same because it's a different vendor, but hopefully it'll give us an idea of what's meant to be there and what's not. So they're missing on the original board. That all looks good. Those two are also missing on the original board. Two missing up there, which aren't meant to be present either. That's not meant to be present. Got two capacitors which I think are meant to be present up just by the memory here. So we'll put them back. And then we might have missing components up here. So this driver and this driver is the same. They're flipped 180 degrees, so this corner It's the same as this corner. You can see above we have a resistor, a capacitor, and another resistor. Whereas on this one, we have, I believe, a resistor, missing component, and then there's meant to be a third resistor somewhere. If I follow that trace round, it goes up to there. So I think we're meant to have a capacitor there and a resistor there. I've checked high-res images of this PCB, and there are meant to be components there. So let's take a quick measure. So that first one's 0 ohms, and that's 2.2. Down here we have 0 ohms, and that's grounded, so that's probably where the cap goes. And then we have a 2.2 ohm resistor that's meant to be there. So we'll find some components for that, put those on. But for now, let's just keep going. Those aren't meant to be present. Yeah, and those don't appear to be either. There's a few in the corner. So that's good. I think we just got to put some components back here, 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 and here before we test it. I'll dig out some components and solder them on. Damn it. There we go. That'll do. I guess now comes the moment of truth. Will this card work? Let's get it in a test rig and run memory tests to see what happens. Okay, here goes nothing. Got it in my test rig, and we're going to boot NVIDIA mods and mats, see if it passes memory test. Okay, let's start with LSPCI. And it's seeing a graphics card. So let's list our folders and move to 570.151_5090. And let's go mods GPU test.js -skip rm state. Okay, so it's running mods now. That's good. Oh, we've got a fail. Where has it failed? Is that F? It's got a failure on one of the memory channels. That line that ends in 8. That means that there is a bad bank of memory, or a bad pad, or a bad joint under one of the chips. So let's power this off, get it back on the preheater, and try messing with that VRAM that is flagging as bad. See if we can get it working. Okay, as you saw, we have a memory error, and it appears to be on F1, which is actually the last chip I soldered. It's this one here. I was expecting possibly more memory errors, so only having one bad channel it's not the worst thing in the world. But what I am worried about is whether this is down to VRAM soldering, whether it's down to the core soldering, whether I messed up a reball somewhere. So I was going to reflow this, but I think what I'm actually going to do is I'm going to remove this memory chip entirely and just see if all the joints look like they were made. If all the joints are present, then it may well be a core issue. But we'll cross that bridge when we come to it. Let's get this memory chip removed. So, as you saw, we have a memory error on F1, which is A10, B10, C10, D10, E10, F1, the last chip I soldered. So, as you can see, we have a memory error. So as you can see, we So as you saw, we failed mods and mats with a memory error. The memory error in question is F1, which is this chip here, the last one I soldered. So let's start by reflowing it, just making sure it made good connection. If that doesn't work, we can remove it and see if all the balls made contact. And obviously we'll have to reball it and refit it after that, see if that fixes it. And if we don't fix it by a reflow or a reball, we're going to have to take the core off again, which I really don't want to do. But we'll take things one step at a time, and hopefully we can get this card running properly. Okay, so that seemed to reflow okay. Let's put the card back on the heatsink and run a memory test again. Okay, let's go ls PCI again. And it's still recognized, so we can go current directory 570.151_5090 mods GPU test.js skip RM state. Yeah. I think that command's right. Okay, it's doing something. And it says failed. Script failed to execute. But that's strange because it's not complaining about the memory chip it was complaining about before. I've done everything the same, so I don't know what that means. But I've not used this version of mods on a 5090 before, so I don't know what it's meant to look like. That fail might actually be a good thing, because it still sees the card and it doesn't complain about the memory bank. So let's power it off and boot to Windows, see what we get. Okay, showing in Windows without any errors. Wow, I did not expect that. Let's see, GPU-Z, does it show all the memory? There we go. It's showing the memory, which means all the memory banks are good. Let's see if it launches FireMark. Temps look okay. It's currently running through the integrated graphics, so the FPS might be a little low when I run FireMark, but it's running. Let's see if it displays out from the actual card. Well, that's something. FireMark, I don't think, liked the change of the HDMI from the integrated to the card itself, but 500 FPS, buttery smooth. Temperatures are looking okay. Power draw's looking okay. I think we saved this GPU. I can't believe it works. Yeah. I thought I was going to have to take the core off again. I guess I just didn't get that memory chip hot enough when I soldered it, so the reflow fixed it. Cool. Okay, I guess I'll test this for a little while, and then I can ultrasonic clean the card, put it all back together properly, and give it one final test before it goes back to the customer. I'm back again. I've ultrasonic cleaned the graphics card, and it's looking beautiful. So now all that's left is to mount it to the heatsink, and give it one final test before we get it prepared to go back to the customer. With that, I'm going to say thanks for watching. I hope you liked this video. Hit that subscribe button if you want to see me torture myself with more repairs like this. And see you in the next one.